Greetings, Mr. Sutton here with the AB Calculus 312 Extra Practice Number 2 solutions on derivatives of inverse trigonometric functions. For this problem, I'm trying to take the derivative of this expression. So we'll start by using the chain rule on the outermost function here, which is something to the 7th. Derivative of that is going to be 7 times this something to the 6th power. Moving into the next function, we now need the derivative of arcsine of something. That's going to be 1 over the square root of 1 minus something squared. So negative 5x to the 4th squared inside a square root. Finally, we take the derivative of negative 5x to the 4th. That's negative 20x to the 3rd. And then we're done. For this one, we're trying to take the derivative of this expression. So we start with the chain rule taking the derivative of the outermost part, arc secant of something. So that's going to be 1 over the absolute value of the something here, the 5th root of all this stuff, times the square root of something squared minus 1. So there, all of this is just the derivative of arcsecant of this 5th root. But now we need to take the derivative of the next function in, the 5th root of something. Well, derivative of 5th root of something, that's really derivative of something to the 1/5 power. So that's going to be 1/5 times this x to the 7th plus 5 raised to the negative 4/5 power. Finally, we take the derivative of x to the 7th plus 5, which is just 7x to the 6th, and we call it a day. To take the derivative on this one, we're going to use the chain rule. The outermost function here, we have arc cosine of something. Derivative of that is going to be negative 1 over the square root of 1 minus something squared. So this whole squared parentheses is being squared and subtracted inside a square root. Next, we have to multiply by the derivative of something squared, which is going to be 2 times the something to the 1st power. So there you go. Finally, we have the derivative of 9x to the 6th plus 10. So that's just going to be 54x to the 5th. And that one's done. On this problem, we're trying to take the derivative of arctan of something. Using our chain rule, we've got 1 over 1 plus something, this square root here, squared. And then we have to multiply by the derivative of this square root. So derivative of square root of something is going to be 1/2 something to the negative 1/2. And then finally, derivative of 5x to the 5th plus 8 is 25x to the 4th. For this problem, I'm trying to take derivative of arc cotan of something. So derivative of that, we're going to have negative 1 over something squared minus 1, or plus 1 rather, plus 1, there we go, because it's arc cotan. And then we have to take the derivative of the something. So derivative of something to the 7th is going to be 7 times this something to the 6th. And finally, we multiply by the derivative of the innermost function, the derivative of 7x to the 9th minus 8. That'll be 63x to the 8th. And we call it a day. On this problem, we just want the derivative of cosine inverse, or arc cosine as you might also know it. That's going to be just negative 1 over radical 1 minus x squared, and that's going to be choice A. For this problem, we have a table given with values of f and f prime. And for part A, we're defining g as a function with ln of x over f of x cubed. Based off of this, we want to find g prime of 2. All right, well, we're going to need the quotient rule for this one. That's u prime v minus uv prime over v squared. We'll use the box and ribbon to help us here. So numerator is going to be ln of x. That goes up here. Denominator, f of x cubed, will go over here. And the derivatives, ln of x, that's going to be 1 over x. And for f of x cubed, we need the chain rule. So that's going to be f prime of x cubed times the derivative of x cubed, which is 3x squared. And at this point, to find g prime of 2, we need to plug 2 into all of these things. Now, you can do this before or after you substitute back into the form of the quotient rule. I'm going to do this inside the box. So if x equals 2, inside the box, let's see what each of these parts becomes. So ln of x is now going to be ln of 2. F of x cubed is now f of 8. Which, looking that up in the table, has a value of 6. And down here, this is going to be 1 over 2. And then finally, this is going to be f prime of 8 times, let's see, 3 times 2 squared, that's going to be 12. So f prime of 8, that's going to be 1/3. 12 times 1/3 is going to be 4. All right, multiplying this back out using my ribbon, I've got g prime of 2 equaling 1/2 times 6, which we can simplify that in a minute. Minus, we've got ln of 2 times 4, or 4 ln of 2, all over v squared, so 6 squared. And simplifying this a little bit, this is really 3 minus 4 ln of 2 all over 36, which we can't really get any better than that, so we're just going to call it a day. On this one, I've got this h function defined as f of negative 3 of x. We want h prime of negative 1. So let me start by taking the derivative of h. That's going to be a big chain rule here. So we're going to have f prime of the stuff inside times the derivative of the stuff inside. That's going to be another chain rule. So that's going to be f prime of something. So f prime of negative 3x times, now we have to multiply by the derivative of the innermost function. Derivative of negative 3x is negative 3. To make this a little easier, I'm going to move the negative 3. Well, actually, let me just substitute negative 1 in for everything. There we go. To make this a little bit easier to look at, I'm going to move the negative 3 out in front. And now I've got f prime of f of, I'm just going to call this 3. This is going to be f prime of 3, just to make it a little bit easier to look at. Let me also figure out f of 3, and then I'll deal with the f primes. So f of 3, looking that up in the table, that's going to be 2. So this first f prime is really f prime of 2. Okay, so we've got negative 3 times f prime of 2. F prime of 2 is 3/2. So negative 3 times 3/2. Now we're multiplying by f prime of 3. That's going to be negative 2 over 5. And we can simplify this a little bit. The negatives cancel, the 2's cancel. We've got 3 times 3 over 5, so that's going to be 9/5. For this last one, we've got k defined as f of x times arctan of x over 3, and we want k of negative 3. So I'm going to need the product rule to take the derivative of this product, so that's u prime v plus uv prime. Let me set up the box and ribbon for this again. So we've got factors of f of x and arctan of x over 3. Derivatives are going to be f prime of x, and derivative of arctan of something, because this is a chain rule, that's going to be 1 over something squared plus 1. But now the something is x over 3, so the derivative of that we're multiplying by is 1/3. Okay, let's actually plug negative 3 in inside the box, and then I'll put it back together out here. So f of negative 3, that's going to be negative 9. We've got arctan of, this is essentially negative 3 over 3, or negative 1. That's going to be like negative 45 degrees, but we're using radians in calculus, so that's going to be negative pi over 4. And then down here, f prime of negative 3, that's going to be negative 7 over 2 from the table. And then finally, this is going to take a little bit of doing here. We've got negative 3 over 3 down here being squared. So that's really negative 1 squared, which is 1. 1 plus 1 down here is going to be 2. So this is going to be 1/2 times 1/3, which we can simplify to 1 over 6. All right, multiplying that all out, we've got negative 7 over 2 times negative pi over 4. Going the other way on the ribbon now, we've got negative 9 times 1 over 6. And we could leave it like this, but if you wanted to simplify a little bit further, in the first term, these negatives are going to cancel. We end up with 7 pi over 8. And then for this next one, we're going to have negative 9 over 6, which we can reduce to negative 3/2.